Hi, I'm Mr. Peacock, and today we're going to talk about solving radical equations. Pew pew. Radical. A radical equation is an equation that has a variable inside of all things, a radical, or a variable with a rational exponent. And if you remember from the last lesson, which was rational exponents are really just radical equations in disguise. So for today, what we're going to do is we're just going to solve some radical equations and make sure we understand why. Now, there are a couple things you need to remember. Number one, what you need to remember is that the square root of something like the square root of 36 is 6. For our purposes, the square root of 36 is not negative 6. So the square root of 36 is going to be positive. The square root of any number is positive. Now, the second thing that you need to remember on these is our big goal at first is going to just be to get whatever radical expression we have. So like in this case, the square root of 3x minus 2 by itself. So for this first question, the way we do that is we take away 2 from each side, meaning we would suddenly have the square root of 3x minus 2, which would equal 4. At that point, once we have the square root by itself, or the cube root, or whatever type of root it is, what we do is we take the type of root it was, and we raise it to that power. So in this case, we're going to square this side. But because we're squaring one side, we have to square the other. So we end up getting 3x minus 2. That's right, nothing changes inside the square root, but that's going to equal 16. At which point we solve like normal. Plus 2 plus 2, that means 3x equals 18. Then divide by 3, x equals 6. Now, we know x is 6, but what we have to do is we have to go back and check our solution. That's because, well, most of the time these solutions are going to work. Every so often there's going to be a few that seem good, but at the end just don't quite work how they should. So I'm going to try this one. 2 plus the square root of, let's see, 3 times 6 is 18 minus 2. That's going to equal 6. So 2 plus the square root of 16 is 6. That's 2 plus 4, so yes, that one works. All right, let's try this one. So in this case, we have two things we need to do. First, we're going to get rid of this minus 6. I'm going to add 6 to both sides. Please always do plus and minus, adding and subtracting, before you do any multiplying or dividing. That's just good planning. So in this case, what we end up getting is 3 square roots of 5x plus 1 equals 6. Then we're going to divide by 3. The square root of 5x plus 1 equals 2. Then we're going to square both sides. 5x plus 1 is 4. Subtract 1. 5x equals 3. Finally, divide by 5. X equals 3 fifths. If I plug this back in, this becomes 3 times the square root of, let's see, 3 fifths of 5 is just 3 plus 1 minus 6. So that's 3 square roots of 4, or 3 times 2, so that's 6. Minus 6 equals 0. So let's see, 6 minus 6 is 0. Yep, meaning our answer is good. So let's try this one. Ooh, this is not written as a radical. It's written as one of those rational exponents, which, quick reminder, is a radical in disguise. So first step here, we still need to get this part by itself. So we divide both parts by 2. This ends up getting x minus 2 to the 2/3 equals 25. Now, at that point, I'm going to raise, I want to get this to be like it's being raised to the first power. Because if it's to the first power, I can take away the radical. I can take away the exponent completely. So the way that you get 2/3 to become 1 is you multiply it by its reciprocal. So we are going to raise this to the 3/2 power. All right, Now on this side, that becomes x minus 2. Now let's check on the other side. If I do the square root of 25 cubed, that becomes 5 cubed, or 125. Now, if you want more about how to simplify, please go into earlier lessons where we talked about that. Now, you can also theoretically put this in a calculator and do 25 to the 3/2 power if you would prefer. But either way, what you end up getting is x equals 127. That's our answer. Yay! Okay, so let's try this one. So our first step is going to be, like always, adding 5 to each side. That ends up getting us 3 times x plus 3 to the 3/2 equals, in this case, 81. At that point, we divide both sides by 3. X plus 3 to the 3/2 is 27. Ooh, that's a number I recognize. And so at that point, I'll raise this to the 2/3 because that's its reciprocal. Let's see. The cube root of 27 is 3. 3 squared. So we get x plus 3 is 9. Sorry, I didn't put the parentheses around x plus 3 like I was supposed to. So x plus 3 is 9, which means x equals 6. So let's see. 3 times 6 plus 3 is 9. Square root of 9 is 3. 3 cubed is 27. So 3 times 27 is 81. Minus 5 is 76. Yep, this one works. Yay! All right. Oh, wait a second. Look at this. If we go back to this question right here, you'll notice we were saying check your solutions. We're now specifically saying check for extraneous solutions, meaning some of these answers will work perfectly while we search it, but will not work once we actually put them in. We're going to start seeing that now. Now, with this equation, what I like to do personally is I like to get each square root on opposite sides of the equation. So the way I'm going to do that is by adding this second square root to both sides. Meaning we get the square root of 3x plus 2 equals the square root of 2x plus 7. Now, both sides will just square, which gets us 3x plus 2 equals 2x plus 7. At which point, I'm going to take away 2x from each side. X plus 2 is 7. Then I'm going to subtract 2. X is 5. At which point, since x is 5, I put this in. Square root of 15 plus 2. Let's rewrite this a little bit smaller. Square root of 15 plus 2 is 17, minus 2 times 10 is 10. 2 times 5 is 10, plus 7 is also 17, equals 0. Is the square root of 17 minus itself 0? Yes, it is, so we're good. Yay! All right, let's try this one. So you'll notice this time it says 0.5. Remember, x to the 0.5 is the same as the square root of x. Meaning, we're really just going to do the same thing. Our first step is move over the 3x plus 4, at which point we get the square root of 2x plus 1 equals the square root of 3x plus 4. At which point, square both sides, square, square, 2x plus 1 equals 3x plus 4. Subtract 2x from each side. 1 equals x plus 4. Subtract 4, subtract 4. Negative 3 is the same thing as x. So then I just plug that in. So let's see. Negative 6 plus 1 is negative 5 to the 0.5 minus negative 3 times 3 is negative 9 plus 4 is also negative 5 to the 0.5. And that equals 0. So as you can see, we are subtracting a number from itself, which would be 0. But because both of these are square roots of negatives, they would be imaginary, meaning It might be extraneous. I would say it's extraneous because the imaginary numbers don't exist. So technically extraneous. Okay, let's try this one. So in this case, what we would do first is we would try to get the square root by itself by adding x. So the square root of x plus 7 ends up equaling x plus 1. At this point, we square both sides. Now, this is where I see a lot of people make a mistake because they think they can just say x squared plus 1 squared. But remember, we have to FOIL out x plus 1, which ends up getting us x plus 7 equals x squared, and then it's going to be times x plus x times plus x. So that'll be plus 2x and then plus 1. At that point, I want to get everything onto one side. Now, you might be wondering why, and the reason why is we want it all to be on one side so we can then factor this as a trinomial. So minus x minus 7 minus x minus 7. We end up getting 0 is x squared plus x minus 6. So two numbers that multiply to be 6 have a difference of 1, are 3, and in this case, negative 2. 3 and negative 2 ends up getting us, so we have 0 equals x plus 3, x minus 2, meaning x could equal negative 3 or 2. Now what we're going to do is just check for extraneous solutions. Our first one we do is negative 3, the square root of, let's see, negative 3 plus 7 is 4, minus negative 3, so plus 3 equals 1. That's 2 plus 3 is 1. That means 5 is 1, so it's not negative 3 for sure. Now let's put in 2. Square root of 2 plus 7 is 9, minus 2 equals 1. That's 3 minus 2 is 1. 1 is 1. So x equals 2. Confirmed. Now let's try this last one. We square both sides. In this case, we get 3x minus 2 equals x squared. And in the middle, you'd have minus 2x, so minus 4x in the middle. At which point, minus 3x plus 2, minus 3x plus 2, x squared minus 7x plus 6, two numbers that multiply to be 6 and add up to be negative 7 will be 1 and 6. 0 equals x minus 1 times x minus 6, meaning our two possible answers are x equals 1 or 6. Let's plug in our values to see which one is correct. So square root of 3 minus 2 equals 1 minus 2. So let's see, square root of 1 is negative 1. That means 1 is negative 1. Nope. All right, so now let's try 6. Square root of 18 minus 2 is 16 equals, sorry, I'll actually write this one out a little more. 18 minus 2 equals 6 minus 2. Square root of 16 is 4. 4 is 4. Yep. X equals 6. And that is our answer. Thank you very much for watching. That is it for this video. If you would, please like, subscribe, watch my prior videos. This is the end specifically of the radical unit. So if you watch this selection of playlist that you see right up here right now, you can see all of the radical unit to prepare for any future tests that you might have. Thank you. Have a good day. Goodbye. See ya.